Okay, this is Rges Algebra 2, Lesson 9A. It covers in your textbook sections 2.5 and 2.6. Now we're still talking about difference of squares. So remember, if I had, let's say, 4a squared minus 9. This is something squared, and this is something squared. And so I'm rewriting that. Often you're doing it in your head, but that's what you're thinking, and then the answer would be the sum of the two times the difference of the two. And of course we know that it can get complicated because the second one might also be the difference of squares, and so you might have to break it down another time, or you might have a common factor. So we've already talked about those things, but this is the basic idea. Now we want to show you today how it can look very complicated, but you can still use this same basic principle. So here's the first one, 25a squared minus 3a plus 2b squared. Now notice this is already something squared. Just looks like a mess, but it's just something squared. If I had this as 5a squared minus 3a plus 2b squared, then I've got the difference of squares. Just like above, the answer would be a sum where you're adding this and this. So it would be 5a plus 3a plus 2b, and a difference. So it would be 5a, again, the whatever you're squaring, minus 3a plus 2b. Okay. So the basic idea, difference of squares can factor to a sum and a difference. Now, we can't leave it like that because we have variables that can be combined. So I need to clean this up a little bit. 5a plus 3a is 8a plus 2b. I'm going to combine the like terms here. 5a minus 3a would be 2a. And now my b's will have to be minus because I have to distribute that. You could do this in another step, of course. You could do it as 5a minus 3a minus 2b and then combine. That's probably a good idea if you want to be accurate here. And minus 2b. Okay. Now it's looking pretty clean right now. That looks like a pretty good answer, but it's not acceptable yet because I have, in the first binomial, I have a common factor. So I can factor that out, leaving me with 4a plus b. And in the second one, I have a common factor. So I can factor that out, leaving me with a minus b. Now I'm almost done, but I have one last step. I will combine these two multipliers and bring them forward. So this becomes 4 times 4a plus b times a minus b. This is messy, but not complicated. In other words, the basic concept is not even a new one. It just results in lots more steps and places you could actually make lots of errors. But the basic idea is fairly straightforward. So before you go on, I want you to pause, go all the way back to the original problem, and see if you can't duplicate these steps. Now let me do it again for you after you have done that. So I would really recommend you take the time to practice that. Okay, let's show you another one. After you come back to me. 3a minus 2b squared minus 2a minus 5b squared. This is, again, just simply the difference. Here's something squared minus something squared. So this is the difference of two squares. Okay. So the first one would be plus, and the second one would be minus. What goes in this first? Whatever's in the first one here. 3a minus 2b. What goes in the Second one here, whatever was up here. Ignoring this sign, right? Because we're dealing with the plus and the minus here. So just what's in the parentheses. Again, what's in the first group? 3a minus 2b. Oops. And now minus, that's a 2b. 2a minus 5b. Sorry, I didn't give myself much room here. Let's try to quit being so sloppy here. Minus 2a minus 5b. There we go. Just like that. That's 3a minus 2b. Now, again, I have to clean it up. This is my... I really got it messy here. Okay, that's my first section. So my A's, well, let's see. How would I do this properly? Okay, I'd go take away this set of parentheses, take away this set of parentheses by, I don't need to distribute anything because it's a plus before it. And then on this one, it'd be 3a minus 2b. And now distributing my negative sign, minus 2a plus 5b. So as long as you're being very deliberate, I'm running out of room here. I'm going to clean this up by gathering like terms. I'm going to get 5a minus 2b minus 5b is minus 7b. In the second section, I'm going to gather like terms. 3a minus 2a is a. Minus 2b plus 5b is plus 3b. No more simplification than that, and that's going to be my final answer. So that will take you through 1 through 17. They're just the same odd, okay? Now let's look at the next idea. And again, you have to be careful, and the reason you have to be careful is there's a lot of little places you can make errors. But the overarching idea is just the sum and the difference. Difference of squares equals the sum and the difference, two binomials. Okay. Now, the next section is also can be beginning a little complicated. This, I would say, is more complicated. This takes you to the sample solution at the bottom of 49. It says a squared plus 4 minus c squared minus 4a. Now, a lot of times you can't make this fit the difference of squares pattern, but I do notice that this is something squared, and I could look, and even though this is something squared, I've got these extra terms, but one of these terms is also an a term. So if I look at this, this, and this as a binomial, let me flip things around. Now I'm going to have a squared minus 4a plus 4 as a trinomial minus c squared. Well, this is, right here, something squared. Can I rewrite this trinomial as something squared? Well, hopefully you recognize that as a minus 2 squared from back in your days of factoring a trinomial. Now I have something squared minus something squared. See how that works? Now I can apply my plus and minus. What goes here? Same thing as here. A minus 2. What goes here? Same thing as here. What goes here? Same thing as here. And what goes here? Same thing as here. Okay. They don't really simplify like this, so I could reorder it with all my variables first, but that's a perfectly good answer, just like that. Now remember, you might have to pull out a common factor, and you know how they like to do it. They like to mess you up. What you're looking for, though, is, let's look at 19, 21, and 23 quickly to give you a little bit more of an idea. Okay, 19 says this. I'll give you kind of a jump start. Yeah, actually this one's already given you the jump start. They've said, okay, we want to rewrite that as something squared. Okay, and so you can do that one. That's not that hard. Okay, but let's look at 21. 1 minus 4q. Actually, this isn't that hard either. I thought they'd make them a little more messy for you. Okay, so I'm thinking of this, rewriting that as a binomial squared minus that. And then going ahead and doing my plus and my minus. The last one is the one that I'm looking for that's a little bit messier. You probably could figure it out just on your own. Okay. These three go together because we have an A and a B term over here. So we could rewrite this. Now watch what happens. If this is a difference, I need to group this after a minus sign. So watch my signs carefully, carefully. A squared, put the middle term, what would be the natural middle term, plus, you see why? 2ab, because I'm going to have to distribute a minus sign to go back to the boxed portion above. And then plus b squared, sorry. Okay, so can I rewrite that as a binomial squared? That would be a plus b squared. Make sense to you? Okay, so then, of course, continue on with the problem. I'm not solving it all. I'm just giving you a hint on how these start. Going back, just in case. Okay, this one would be a minus x squared, because this would, if I went ahead and did FOIL back, I get a squared minus ax double plus x squared. This one would be, because if I FOILed back, I would get 1 times 1 for the first term, multiply them together, minus 2q and double for the second term, and 4q squared for the third term. Okay, so I went ahead and did that and that for you. And you should be able to do the rest. This is as complicated as it's going to get. And that would be 2.5. Now let's go on to 2.6. 2.6 is talking about cubes. There are two formulas to remember. A cubed plus b cubed is going to equal a binomial, simple binomial, a plus b times the simple trinomial formula, which would be a squared plus, or I'm sorry, minus ab. It's not quite the simple, because the one we're used to, the perfect, would have a double there. So this does not have a double, just the multiplication, plus b squared. Now let's talk about signs. If this is plus, and this is minus. This is always plus. So if we go the other direction, by doing a subtraction there, the first one is going to match a minus b. We're going to do the square. We're going to do the opposite sign, plus. We're going to multiply them together. The last one's always. So play with the formulas till they get real familiar with you. The first several problems are simply helping you memorize it. How it's used then, let's look at number 3 to understand how this is used. We would need to write this as something cubed, so I'd rewrite this as x cubed plus 2 cubed. Now I'm ready to use the formula. The formula says take the first term and add it to the second term, x plus 2, square the first term. We're going to take the opposite sign, subtract, multiply them together, always add, square the second term. See how that works? Well, let's do several more for you so you get comfortable with this. Let's look at 4. y cubed minus 125. Okay, this is already written as a cube, something cubed. Okay, so we go y cubed. I could write this as something cubed. So we've got something cubed minus, in this case. Notice it could be either plus or minus as long as both terms can be cubed. Something else cubed. Now that's going to be, take the first one with the same sign. First term, y, same sign minus. Second term, 5. Then square the first term. Opposite sign from the negative. Okay. Multiply the two terms together, 5y. Always a plus. Square the second term. That's all it is. It's almost just like plugging it in. Just going to get some more complex examples. Now let's look at some other things that could come up. What if we had the sample that they give you in the middle of the page, r to the 6 plus s to the 6. We'll rewrite things as cubes. This would be r squared cubed plus s squared cubed. So this is that cubed plus that cubed. The formula is the same. Take the first term, same sign, second term. See how this is working? Square the first term, so we're squaring what? The r squared, so that would be r to the 4th. Opposite sign. Multiply the two terms together. Always a plus. Square the second term. S squared squared is going to be s to the 4th. So now we're taking something to the 6th, but we're rewriting it as a cubed. The next one is the same way. And don't forget, so you should be able to work your way down these. Don't forget, sometimes you might have to take out a common factor first. So don't forget that. And I've assigned, let's see, let me see if there's anything else tricky. Number 9 looks tricky until you recognize that you have a v as a common factor, and then you can write that more easily as things cubed. Let's see, 11 is straightforward, but you're going to have two terms, your x minus y, as a combination. Okay, so you should be able to do that. You should be able to do 13. 15, I'll get you started on 15. Try it on your own before you look at my hints, but if you need a hint for 15, okay. I can't pull, well, I could actually pull out a so do I want to is the question mark. I can't pull out an 8, so it's, oh no, I can't. I'm sorry, I was looking at a different problem. Okay, so rewrite this as something cubed, right? So this would be the same as 2m plus n, the whole thing cubed, plus 5n, the whole thing cubed. And now you should be able to just apply your formula. It gets a little longer, but the basic idea is the same. 17 is a little complicated because I'm going to tell you what it is as far as the 343. Hang on. Okay, you might not have recognized 343, but it is 7 cubed. Okay, so knowing that, the rest of it you should be able to do. All right, I will also tape a answer key for test 2.